Hey, oh. Okay guys, hey, we are going to just do one thing really, really quick, and we're going to talk about the ideal voltmeter and the ideal ammeter, and that's it. So here we go. It's going to be really fast. First, the ideal ammeter, the ideal voltmeter. Alrighty, so what do you suppose the voltmeter is measuring? Oh, if you're thinking volts, you're correct, hence the name. Volts for volt and meter for measure. And so suppose we had a circuit. I'm just going to draw some random circuit, okay? So you can draw this too, and don't make it pretty. Here's V, here's R1, here's R2, and here's R3. Here's my circuit. And I've got my voltmeter. And my voltmeter is just a device with, here's the black lead and here's the red lead. So I'm going to have to hook my voltmeter up. And I want to hook it up, suppose I wanted to hook it up to measure the voltage across R3. I want to measure the voltage drop across R3. You tell me, how should I hook that voltmeter up? Should I hook it up in series with R3 or in parallel with R3? If I want to measure the voltage across R3. Let's have a vote. How many people say if I want to measure the voltage drop across R3, I should hook it up in series with R3? Okay. How many people say I should hook up in parallel with R3? All right. Earl, why did you say parallel?
Well, parallel circuits will have the same volt drops.
Thank you. Can I just stop you there? I'm going to repeat what he said. Parallel circuits have the same voltage drop. If I want my voltmeter to measure the voltage across R3, I need it to have the same voltage as R3, right? So yeah, if you want to measure someone's height, you need to get a meter stick or a tape measure and extend that tape measure till it is the same height as the guy whose height you're measuring, right? That's how you measure things. The way a thermometer works is you put it in water and you wait till the thermometer has the same temperature as the water, then you read what the thermometer says. Well, it's the same thing here. If I'm going to use a voltmeter to measure volts, I need it to have the same volts across it. And the only way that happens is for it to be attached in parallel. You see? So that's the first thing you need to know about the ideal voltmeter. You must attach it in parallel with the device whose voltage you are measuring. Must be attached in parallel to the device whose voltage you're measuring. Here's the next thing. It is a general rule of measurement, measuring. You're measuring. Here, just a second. Change that. You're measuring. Okay. It's a general rule of measurements that you do not want to make a measurement that changes the thing you're measuring. Correct? Like, for example, if I'm in the supermarket and I'm measuring the weight of my fruit, I don't want to put my fruit in the scale and then rest my arm on the scale, right? Because now I'm changing the measurement of the fruit. Or if I want to measure the temperature of some water, I don't want to stick a hot thermometer into that water and then say, okay, let's get the measurement of the temperature of the water. Because in so doing, you raise the temperature of the water. You see what I mean? Like whenever you make a measurement, you don't want to do it in such a way that you change what you're measuring. Well, this is no different, okay? I've got current coming through here, okay? And that current multiplied by R3 is going to get me the voltage drop across R3. I am now going to hook a voltmeter in parallel with R3 and measure the voltage drop across R3, but I do not want the the attachment of the voltmeter to change the current going through R3, and thus change the voltage that I measure across R3. So here comes my next question. The ideal resistance, the resistance of a voltmeter, ideally, should it be 0 or should it be infinity ohms? Think about it. I want to attach it in such a way that it does not change the current going through R3 and thus doesn't change the voltage drop across R3. Should the resistance of my ideal voltmeter be 0 ohms or should it be infinity ohms? Please think about this for a second. Okay, tell me, how many people say the resistance of my ideal voltmeter should be 0 ohms? Okay, 2, 3 of you. How many people say it should be infinity ohms? Okay, 1, 2, 3, 4 of you, maybe. Okay, and the rest of you, I guess, are non-committal. Earl, or no, I already called on Earl. Who else was it? Pooja. Why did you say 0?
I don't know.
Okay. Who else said 0? Gavin, did you say 0? Gavin, why did you say 0 ohms? Why is it better for the voltmeter to have 0 ohms?
If the voltmeter has 0 ohms of resistance,
Yes.
then then I'm sorry, I'm having trouble explaining this. I just know that if there's 0 ohms of resistance, it's better for it to be able to measure the change in voltage between the 2 points.
Okay, great. He just has, it's mostly intuition, I guess. All right, Sean, you went with infinity. Why would you go with infinity?
Well, I was like, if it's going to be like a path of least resistance,
Yes.
then it would go through R3 over infinity. But
Okay.
then that makes no sense.
Okay, well, let's consider what Sean said. Sean said, I want all of that current to go through R3, and I know current goes through the path of least resistance, so if I make my voltmeter's resistance infinity, then all of this current will go through R3, and none of it will choose the voltmeter. Is there anyone here convinced by Sean's logic? Okay, good for you guys. It's about 5 or 6 of you. I just want to tell the video audience I have 5 or 6 un-American people because they were convinced by logic, and like I always say, you're not American if you're convinced by logic. I don't know what else to tell you. I mean, what Sean said was exactly right. I can't really elaborate on it anymore. Are you guys okay that as long as that resistance is infinity, none of that current gets leached into here, right? I don't want any current to get leached into the voltmeter. I want no current to flow through the voltmeter. I want R3 to get every bit of that current and none of it to go through the voltmeter. And the only way that can happen is if the resistance of the voltmeter is infinity. So there it is. And that's the reason why you don't want to leach any of the current away from R3. You want all of that current to go through it. Any question or problem on this? Okay, hey, let's do the ideal ammeter. The ideal ammeter. What does an ammeter measure?
Amps.
Yeah, amps. Amps. I mean, I don't know why it's called an ammeter instead of an amp meter. I mean, if that's an ammeter, why isn't this a voltmeter? But I don't know, whatever. Ideal ammeter. You tell me. Let's go ahead and make the same circuit. Okay, here's R1, here's R2, here's R3, here's my voltage. Now, let's say I want to measure my current through R3. I want my device, my ideal ammeter, which again is just a device with a red lead and a black lead. I guess I'll put the black on the right since I did it over there as well. But there's a red lead and a black lead. Alrighty, here's my ammeter. I want my ammeter to have the same current going through it as R3. So how should the ammeter be wired? In parallel or in series? How many people say in series? Yay, good for you guys, because that's what series wiring is. They have the same current. Okay, so must be attached in series to device whose current you're measuring. Just because with series wiring it has the same current. So let's go ahead and disconnect these two wires and insert my ammeter. There's my ammeter. And you tell me the ideal resistance of the ammeter. Should it be 0 ohms or should it be infinite ohms? Please think about this for a second, then we'll vote. Remember, I do not want to affect the current going through R3. How many people here say the ideal ammeter should be 0 ohms? How many people say infinity ohms? Okay, so I'm going to explain to the class, why would infinity ohms be wrong? Why is that a bad idea? Before the bell rings. Let me just do this. We'll put this in a cloud. Tell me, yeah, Gavin.
Yeah. For the opposite reason of the voltmeter, since with this one you want as much current as possible to go through it so it can tell how much current is going through.
Thank you. For the opposite reason. You want as much current. What if this was infinity? You've got this current here, and it's splitting into I1 and I2, right? Tell me, what would I1 be if that guy's infinity, resistance was infinity? Well, how much current would choose that path?
None.
Yeah, none. You'd get 0. That's not a very useful device. Every time you measure current with it, you get 0. That's not very useful. So yeah, you need it to be 0 ohms. Okay, last thing, I know the bell's about to ring, but the ideal voltmeter, you need it to have infinity ohms. Well, let's say my voltmeter was 1,000,000 ohms, but it so happened that this resistance was also 1,000,000 ohms. What would happen to the, how would the current be split? If this were 1,000,000 ohms, but that was also 1,000,000 ohms?
Half and half?
Yeah, 50-50, which means you would measure half the voltage. And so you would have to do something special. And if any of you become electrical engineers, when you measure incredibly high resistances, sometimes you have to take that into account. Okay, bye-bye.